Hello and welcome to another math lesson. Today our objective is I can find the area of acute triangles. And so just as a quick reminder, acute triangles, they all have angles that are less than 90 degrees. Yesterday we talked about right triangles. Today we're talking about acute triangles. So without further ado, let's go ahead and take a look at our first example. Example number 1. So here we do in fact have an acute triangle, and a couple of things you might notice here. You might notice that we have all of our sides labeled. We have 12 inches, 10 inches, 9 inches, and also we have this section in the middle of 8 inches. Now keep in mind, the area of a triangle is still the same as it was yesterday, especially when we talked about right triangles. And that area is 1/2 base times height. Or you can think of it as base times height divided by 2, because that is essentially what we're doing when we multiply by 1/2. So when I look at this, there's a couple of things going on. When I choose my base, I'm actually going to look for the height first. And the height is actually the number that goes up through the triangle. It tells me how tall it is. I don't want to use this angle, or, sorry, not this angle, this side length or this side length. Instead, I'm going to use the two numbers that intersect. So notice right here, we have this right angle here, and it intersects with this base of 10 inches. So when I do this calculation, my base is going to be that 10 inches, and my height is actually going to be this 8 inches. It's important that when we do this, we find the height first, so I look for where that dotted line is in the center. The height could also be out to the side, so you may also see the height written out here, and it might say 8 inches. I have to know it's the height because it's how tall the triangle is in the center. Sorry, it got a little bit blurry. See if I can refocus it. There it goes. So now I'll just substitute in my values to my equation, and I will solve for this. So I have 1/2 base times height. 1/2, my base is 10 inches, my height is 8 inches, and I will multiply that. I will use a calculator, but in my head I know 10 times 8 is 80. So that's 1/2 times, I'm going to show that using a dot, 80 inches. I know my units, that's going to be 80 inches squared. I'm going to save that for the end. 1/2 times 80, that's really 80 over 2, which is 80 divided by 2. If I were to put that into a calculator and solve, I would find that that is indeed going to be 40 inches squared, or I could say that as 40 inches to the power of 2. So again, when we look at acute triangles, we have to first find that height, and whatever that intersects, it will be in the middle, that will be our base, or maybe a little bit slightly over than the middle. That's example 1. We have one more example to look at, and then we're done with this video. All right, moving on to example 2. We may see more complex acute triangles that look something like this. Notice here we are given several different numbers. It's up to us to determine what numbers we use. But again, our formula is still the same. Its area is 1/2 base times height. So the first thing I do like to find that height in this case. And in this triangle, there's actually going to be two different ways to solve it. I'll show you one way, and then I'll show you option 2, which is actually the way I like to do it. But I do want to show you that there are actually two ways to find the area of this triangle. So first things, I look for the height, and I know that that's going to be in the center, or splitting my triangle into really two triangles. So I know that height is going to be 12 centimeters. I'm actually going to put that over here. Height is 12 centimeters. However, when I look down at the base, I notice that I'm actually given two numbers. I'm given 9 centimeters and 12.6. So the question becomes, what do I do to find area for my base? This is option 1, which is a little bit longer, but it is an option. If we think about this acute triangle as being split into two triangles, we could find the area of both the green triangle and the purple triangle, and then add together those two areas to find the total. So if I were to do this, I know that the height is 12, and for the green triangle, the base is going to be 9 centimeters. So I'm going to put a little green triangle over here, so you know I'm talking about the green one. I would first solve for that area. So what that looks like again, it's 1/2 base times height, which is 12 times that 9 for the green triangle. So that's 1/2, 12 times 9. One thing I might want to do here, especially if I do not know my multiplication facts, I will want to pull up a calculator and use that. So I would just do 12 times 9, which is 108. So that's 1/2 times 108. That's really 108 divided by 2. When I do that, I find that this is 54 centimeters squared. But I'm not done yet here. I still have to find the area of the purple triangle. So I'm going to go ahead and do that. And I'm sorry if you hear some meowing. That is my cat. My cat is in my office with me, and he just jumped up on the back of my chair. So sorry for the meowing. All right, now to find the area of that purple triangle, we would do the same thing. 1/2 base times height. The height is still that 12 centimeters, so I would write 12 centimeters here. However, I have to look on the purple side right here to find that new base, which is going to be 12.6. I will bring out, my document camera froze. There we go, it is now unfrozen. I now bring out my handy dandy calculator and I will solve this problem. 12 times 12.6, that's 151.2, and I have to divide it by 2. When I do that, I get 75.6. And I'm not done yet. Now that I have found the area of both the green and the purple triangle, I'm going to have to add together these two numbers. So my final thing is to add the area of both of them, which is 54, plus 75.6. Again, calculator, I already have 75.6 in there, so I'm going to add 54, and I get 129 centimeters, sorry, 129.6. I'll make that an extra large decimal point, 0.6, and we can't forget about our units, so we got to put in, I'm going to scooch up that paper, centimeters squared. Okay, that's option 1. Now, some of you might be thinking, geez, Miss Fisk, that's going to take a lot of time. Why don't we just add the two numbers on the base together to get one base? That's exactly the way I would do it for option 2. So I'm going to move my cell phone over here. This is what I would do for option 2. I would honestly take these two numbers and add them to get that total length of the base. So that'd be my first step. I'm going to add those to get the total base. That is 9 plus 12.6. 9 plus 12.6. And when I do that, I see that the base, the total base, I should say, is 21.6 centimeters. Now that I know that, I just have one base, one height, and one formula. I'm going to solve that now. So that will be, area is 1/2, base times height. That base is 21.6. That height is 12 centimeters. I will multiply and solve this now using my calculator. 21.6 times 12. And then I will divide that by 2. And notice, we indeed did get the same answer as over here, which is 129.6 centimeters squared. Two different ways, two different options, but we still got the same answer. So again, on this problem, you can either decide to add together your bases and then multiply it times the height, or you can treat this as two different triangles. You can choose what path you'd like to take. So in review, in summary, when we're solving for an acute triangle, we have to find the base and the height. The height will typically go in between. It will bisect this line here, which is the base, You don't want to use the edges that it does not directly intersect at a right angle. So do be careful when you're choosing which one is the height and which one is the base. That's all I have for you. Today's objective again was I can find the area of an acute triangle. Please go ahead and get started on your problem set. I'll talk to you guys later. Bye.